Welcome to part 2 of the lesson. Now we're going to look at potential difference in parallel. So potential difference, sometimes called voltage, is the work done per charge or the energy transferred per charge. So the battery is going to transfer some energy to each charge, and that charge will transfer its energy to the other things in the circuit. So again, imagine you're an electron on your day out. What's going to happen? You start in the battery and you pick up some energy. Maybe you pick up 6 volts of energy. When you come to the split, you have a choice. You can either go in the top branch or you can go in the bottom branch. But it doesn't matter which branch you go down, you still have the same amount of energy. So if you had 6 volts at the start and you went over the top branch, you would also have 6 volts. If you went on the bottom branch, you would also have 6 volts. When you get to the other side, you will have 0 volts left until you go back to the battery, and then you pick up 6 volts again. So potential difference in parallel is going to be the same on any parallel branch. So you might see it drawn like this. We're measuring the potential difference in parallel. So the voltmeter will tell us the voltage or the potential difference across each resistor. They will all read the same. So if this was 6 volts, this will be 6 volts, this will be 6 volts. All right, potential difference is always the same in parallel. So super easy example. If this was 8 volts, what are each of the voltmeters going to read? Well, although we have 3 resistors in parallel now, they're still in parallel. They're all connected to the battery. They're all going to read 8 volts. So every single one of these will read 8 volts. Another example for you. Now we've got a slightly different parallel circuit with 2 resistors in series in each parallel branch, but this is still in parallel to this. What is each voltmeter going to read? Well, again, we've got 12 volts over the battery. This parallel branch will also read 12 volts. This parallel branch will also read 12 volts. Supposing I'd said, what's the potential difference just over this one resistor here? Well, it's 12 volts over both of them. So what's one going to be? 6 volts. So what's the other one going to be? 6 volts. 6 plus 6 is 12. Great. What about this one? 6 over this one. 6 over this one. 6 plus 6 is 12. So we've got 12 volts over both of them, which is great because that's what the battery is. So have a look at this example. See if you can tell me what the potential difference across just this resistor will be, across both the resistors, and again across both the resistors here. So it should be fairly easy. It's 10 volts across the battery, so it must be 10 volts across both of them. So this one on its own will be 7. Must be 10 across both of these. And we can assume, if we haven't been told, that these are identical, so we could say there was 5 across each one. But really, I only asked you to do 10 volts across both of them. So here is all the information summarized. So you can pause the video now, make some notes, and then complete the questions on potential difference in parallel.